this presentation, I would like to give an overview of the first prototype of ECPD toolkit, explaining its components and the overall architecture. Here we have a holistic overview of the approach that we are using in scope of CoolEmAll to build up ECPD toolkit. So, as previously explained by Ariel, the approach consists of a coupled simulation of workload simulation and CFD simulation. Next slide, please. So the overall architecture of this toolkit of this prototype is presented in this figure. What we have is first of all, application profile, which is capable to capture characteristics of different applications, which later on can be simulated with the data center workload and resource management simulator. Then we have a repository which is populated with application profiles, workloads, and building blocks covering granularity on the server room level, rack level, or node groups level. So we are able to simulate different configurations of racks, for instance, servers or the rooms, and so on. The two main components of the ECPD toolkit are data center workload and resource management simulator, which is actually in charge of assessing the actual power usage of applications being virtually executed on hardware. And for this purpose, we are using models of these hardwares, which are described in terms of power usage based on different load levels. So the outcome of data center workload and resource management simulator are the overall power usage that has been provided so far by applications and their airflow, which are then stored in the database and used as initial parameter for CFD simulation. So the CFD simulation receives parameters from the database, performs the actual CFD simulation, calculates the actual heat flow distribution within the server or the server room, and writes the actual results back in the database where they can be retrieved by a metric calculator capable actually to assess different experiment results with the efficiency metrics mentioned previously. Something to highlight is that the database that we are using contains as well data from the real experiments, also from the execution of real applications on the testbed, and so at the end we have possibility to compare the both results, the simulated results, and the real results captured during the execution of applications. And finally, we have a CoolEmAll Web GUI, which includes so far mob graphic user interface, which actually visualizes some results of the simulation based on data stored in the database. Next slide, please. Thank you. Here again, overview of components. Application profile is implemented currently as a command line tool, so it's capable to capture characteristics of application in terms of resources. In that case, how many CPU is used, how many memory, and so on. What is later used by workload simulator. As mentioned before, workload repository contains application profiles, workload profiles, and data center efficiency building blocks, which are described on different granularity levels and contain models necessary for workload simulation. In that case, power profiles, and of course, geometry data that is necessary for CFD simulation. Next slide. Yeah. So as mentioned before, one of the main components of ECPD toolkit is data center workload and resource management simulator DC-worms. It's actually in charge of simulating workloads and applications. The actual workload and applications contains the actual usage of resources in terms of loads level of CPU, memory, and so on. And the task of workload management of the workload resource management simulator is actually to estimate the actual power usage based, of course, on a profile of the building blocks that are captured that are retrieved in previous text from the DEPS repository. So data center workload resource management simulator supports as well evaluation of different scheduling and resource management policies. So we are able not only evaluate different workload policies, but as well different resource management policy, for instance, trying out how it is, for instance, when we run a resource at lower frequency and so on, how it will be affect the overall power and energy consumptions of applications. As a result, workload simulator actually calculates power usage distribution and heat airflow generation that is then used by CFD component. Next slide, please. So as mentioned before, CFD component is in charge of calculating flow and temperature distribution on different granularity levels, for instance, on server level, rack level, or even within the entire server room. So at the end, it calculates the actual heat and flow distribution map, which can be visualized with the different tools that we are using in project. In the first prototype, CFD simulator is based mainly on OpenFOAM, and it is used in a command line manner. So in the second prototype, we are working on getting this more interactive. Next slide, please. So another components of this little kit is a metric calculator, as mentioned before, which is actually in charge of calculating particular metrics that are necessary for the assessment, entire configuration, and experiments. So far, they have been implemented hardware level related metrics like a thermal imbalance or power usage, as well as energy usage, and application related metrics such as the overall energy that has been so far consumed by a process or the actual temperature for a particular process. In the next second prototype, it will include as well more advanced level metrics mentioned by Ariel. Next slide. The database, mentioned before, contains, in addition to real data captured from the monitoring systems and simulation, as well as simulation results, and this can be easily evaluated and compared against each other. The visualization tool that we use actually visualizes components and surface, geometry and position. It is capable to provide information about the data stored in a database, in that case monitoring data and results of workload and CFD simulation. So this actually enables validation of the models that we are used for workload and CFD simulation.